Let's look at the function f of x equals 3x squared plus 3x. We're going to find the vertex, the x-intercepts, the y-intercept, and graph the function. So to find our vertex, we start by using our formula x equals negative b over 2a. In the case of this function, b is 3 and a is also 3. Simplifying the top, we have negative 3. Simplifying the bottom, we have 6. Negative 3 divided by 6 is negative 0.5. It's absolutely correct if you write this as negative 1/2. I've found that when I am calculating with functions to come up with coordinates for a point on the graph, decimals are just a lot easier to calculate with than fractions. So I'm going to use a decimal coordinate here. Next, to find the y-coordinate of our vertex, we need to plug in this negative 0.5 that we just found for x into our formula. So we have 3 times negative 0.5 squared plus 3 times negative 0.5. So if we calculate this, 3 times negative 0.5 squared plus 3 times negative 0.5, we end up with negative 0.75. So this tells us that our vertex will be negative 0.5 comma negative 0.75. So we'll go half a spot to the left and then down 3/4. So vertically it'll be a little bit closer to negative 1 than it would to 0. Next, let's work on the x-intercepts. To find the x-intercepts of a function, you take the function and set it equal to 0 and solve the equation. Here we have 3x squared plus 3x equals 0. To solve this by factoring, we start by factoring out the greatest common factor of 3x. And we would have 3x times x plus 1 equals 0. Setting both of these equal to 0, we have 3x equals 0, and then we also have x plus 1 equals 0. The first one we would divide both sides by 3, giving us x equals 0. The next one we subtract 1 from both sides, we have x equals negative 1. So we're going to have x-intercepts at 0, 0 right at the origin and at negative 1, 0. So we'll put points on the x-axis at 0 and negative 1. For the y-intercept, here there is no constant term added at the end. It's almost as if we had a plus 0 there at the end. So our y-intercept is 0. And we can see we've actually already got a point on the x-axis or on the y-axis at 0. When you have an x-intercept at the origin, that's where your y-intercept is going to be. Now, if we wanted to get a more accurate graph, these 3 points are really close together. You could always plug in 1 for x and negative 2 just to get a few more points and make sure your graph is accurate. If you're okay with these 3 points as they are, you can just draw a curve that passes through these 3 points and stick arrows on the ends. If you'd like to try the next problem on your own, pause the video now and resume when you're ready to see the solution. For this one, as always, to find the x-coordinate of the vertex, we use the minus b over 2a formula. B for this function is a positive 8. A for this function is negative 2. This gives us negative 8 divided by negative 4. We'll have a positive 2 for the x-coordinate of our vertex. So when we're finding the y value of the vertex, we'll plug in 2 to our function for x. negative 2 times 2 squared plus 8 times 2. We calculate the 2 squared first, leaving us with negative 2 times 4 plus 8 times 2. This gives us negative 8 plus 16, which is 8. So our vertex will be the point 2, 8. 2 to the right, up 8. To find the x-intercepts, we set the function equal to 0. Negative 2x squared plus 8x equals 0. I always like when I'm factoring something when that highest powered term has a negative coefficient. I like to factor out a negative. It's okay here if you factor out 2x or negative 2x. I'm going to go ahead and factor out a negative 2x. Negative 2x squared, when you factor out a negative 2x, you're left with x. 8x, when you factor out a negative 2x, you'd be left with minus 4. Now we set each of these equal to 0. Negative 2x equals 0, and x minus 4 equals 0. The first one, we divide both sides by negative 2, leaving us with x equals 0. The next one, we add 4 to both sides, leaving us with x equals 4. So here we'll have points on the x-axis at 0 and 4. And as with our previous problem, when you have an x-intercept at the origin is also going to be your y-intercept. So now we can draw a smooth curve passing through these points and stick arrows on the ends.